Welcome to today's class on entity relationship model. As I said in the introductory lecture, that we will focus on the design, usage, and design, construction, and usage, and the application aspect of database in this course. For this week's class, our focus is on database design, and the design aspect here, we speak more about the modeling. How do we model database? How do we construct relationship among different entities that are involved? So, what is entity relationship model? Basically, an entity relationship model is a high-level conceptual data model that shows the blueprint of your database. It shows you how to implement the database. It shows the relationship among the entity sets, and it's a pictorial way for you to see the design of any database, the structure of any database. And of course, this is done by using the ER entity relationship diagram, which is basically a diagram that shows you different entity set relationship. For the entity relationship model, there are some important elements that you have to be aware of, and those are the entity sets, the attributes, and also relationship. An entity is any real world object that is distinguishable from other objects. It can be an example of that can be like course, a department, student. So any kind of entity or an object that has a data you can store about itself. So that is what we know as an entity. And an entity set is basically a collection of similar entities such as employees, departments, students. So those are examples of entity set. And an entity is being identified using attributes. So attribute basically shows you the qualities of different entity. Relationship in an entity relationship model shows the association among two or more entities. For example, Yari works in a pharmacy department, and the relationship set is basically a collection of similar relationship. As I said in the previous slide, entity sets is basically objects that exist and are distinguishable from other entities, such as course, room, department, students, and the set is a collection of similar entities. And an entity is basically represented using a rectangular diagram, as you can see from these examples here. Stars, movies, books, and course. Course is an example of an entity. Books is an example of an entity set, so a collection of similar entity sets. An attribute is basically, in order for you to understand what an entity has, what is an entity, you need the attribute. The attribute shows you the quality. For example, the quality for a course entity, the course has to have a code, a name. So these are the attributes. As you can see here, we have attribute 1, attribute 2, and attribute 3. And keys of each entity are underlined. So basically, keys are a unique way for us to identify each information about an entity. We'll discuss more about keys in the subsequent slide and later lectures. Relationship is an association among several entities. It's usually drawn with a diamond symbol between the related entities. As you can see here, you have entity 1 is related to entity 2 with a diamond in the middle. An example is a course. A course as an entity has a course name, code, and a teacher, and is related to a room that has a room name and seats. So this is one example. Making it more concrete, we a course entity. We have a course as a lecture in room, and the relationship among the course entity and room is that there are lectures in the room. So this is the relation among them. So that is an example of how we can relate entity to another entity via relation. So here the relationship is usually often named in a verb form. So each time you make any relationship that will be here, usually it's an action word, it should be a verb. And this is a more detailed explanation again of showing an entity with qualities and the attribute inside. So uh, an entity called course, for example, has the attribute name, code, and teacher. And as you can see, the values for each of these attributes are shown here. You can see the value for the course code, the name of the course, and the teacher for the course. So making a transition into a relationship. So any ER diagram can be easily translated to any relational database schema. So in such case, an entity becomes a relation, and the attributes of such entity becomes the attribute of such relation, and the keys remain keys. So an example with the course entity here, translating that into a relation, making that more glaring. I'll show you that in the next slide. As you can see, oh, okay. Before we go into that, let me just give a little tip about naming policy. Basically, entities are usually an entity will be named in a singular format, an entity name course, but entity sets usually are plural, so like courses. So that's an example that I wanted to add, at least highlight before going into the example. And for entity relationship tips, any entity, if you want to name, is always a noun. It has to be a thing, so it's a noun. It has its own keys and exists on its own. An example here is a course. As an entity, it has the course code as the key, and name, teacher. These are the attributes as I've highlighted in the previous slides. And for a relationship represented in this diamond a sign is usually a verb, and it can only exist in a relationship in a relation to an entity. It doesn't have its own keys. It's always referencing other keys, usually known as a foreign key. So as you can see here in the previous slide, I spoke a little bit about relationship and entity. If we take an example here where we have an entity course, an entity room, and a weekday. If we look at it from the aspect of the relationship, so an entity course is related to there's for example, an entity course has a lecture in room every weekdays. So if we want to make such a relation, the relation here we have the key for course, which is code, and then the name for the room, the key for the room. Like usually these are primary keys. We'll go into keys in the later slide. So the room key, which is name, and the weekday, which has a day as the key. So you can see here that this is usually represented in this format. So the code here is relating to the table course, the entity course rather, sorry for that. It's relating to the entity course and referring to the course code. Same for name, entity, it has to relate to the same key in the room entity and also for the day of the week. So this is something you have to also keep in the back of your mind and use that whenever you're trying to map any relationship. And as I was about to show you the example before, I had to at least explain some important aspects that you should take note of. So usually a relationship between two entities is translated into a relation, and the attributes are the keys of those related entities. As you can see here, the course entity and the room entity. So a course has a lecture in room. When we translate that into a relationship, which is also similar to the previous example I showed you, you can see now that here the lectures in, which is the relation among these two entities, has the key course code and the room key, which is name. So I've been speaking a lot about keys and keys and keys. Let me just give you a little brief about keys, but in subsequent lectures I will go into more details. Basically, keys are necessary in order for us to have integrity constraint. in our tables in database. And we have keys such as primary key, which is a column or group of column, because it can be a composite key that are used to identify the uniqueness in each of the rows. So as you can see in student table here, we have the student ID. So the student ID here is the primary key. So it uniquely identifies Jones as a student. So there can never be any other student with the same ID. And we have a foreign key also, which is another example. And as you can see in the previous relationship I've shown you here, usually any relation will always reference a foreign key. So these for this relation, these are foreign keys as I've explained. So here the foreign key is basically a column or group of column in any database that provides links between data in two tables. So in enroll table here we have the student ID. You can see that they are both the same. So here the enroll table is referencing the students table. So the student ID here now becomes a foreign key, and over here the student ID is the primary key. So this is how you're able to relate data between one table to the other table. This is a little bit of explanation of what I've told you earlier in regards to referencing keys in a different table whenever you have a relation between entities, or relationship rather between entities. So in summary, for this part one, we spoke about entity as an object, such as a person, a department, a student, attributes which are qualities associated with an entity, and entity set, which is basically a set of related entities, and relationship, which is the mapping of two or more entities together, and relation, which is more of the representation of entities and their relationship. So this is the part one. In the next part, the part two, we will speak more about cardinality relationship, basically talking about one-to-one relationship. We'll speak more in detail about this in the part two.